We know which ones you want.
Just make sure these are off.
That probably works.
All right, so our presentation tonight is on the KAS Robotic Telescope. But before we discuss the project itself, just let me give you a little history and a little background, just a brief introduction. So I first joined the Kalamazoo Astronomical Society in December of 1994. So this is actually my, come this December, it'll be my 20th year as a member of this esteemed group. And I've been very proud to be a member of the KAS. As many of you know, we are the largest and the oldest club in the state. And that's pretty impressive considering when you have clubs like Grand Rapids and clubs like the Warren Club that have access to a much larger population. And we are physically bigger than all those groups. Not combined, but still we are bigger than those groups. So I think that says a lot about the club. But when I first joined in 1994, it was sort of a very small group. I believe there were maybe around 24 members at best, as I recall. All the meetings were at the old planetarium at the Kalamazoo Public Museum, which is now long gone. And most of the meetings were just folks talking in the planetarium. I don't really recall any presentations. Before I joined, I had come to some of the meetings just because I had worked at the planetarium, and I figured, well, I should probably check out the meetings once in a while. You know, maybe I'm kind of required to be there working at the planetarium, because I wasn't what you might call a people person back then. I wasn't into big open type groups and stuff like that. I was sort of a loner type. And so I actually kind of came to some meetings in like 1991 and 1992 and 1993. I would often forget to come. You know, I was a student back then, so pretty busy. And I finally did join in December of 1994, where we just had a handful of members. And again, I just don't remember that many presentations. And but there were many of us that joined around the same time. Aside from me, there was of course Mike Sinclair, there was Pete Mumbauer, and Dave Garden, Mike Dupree, other folks like Bill Nigg and John Kirchhoff have been members for years. There were others like Dave Moore. Many of us that joined and wanted to help bring new life into the club. And so things started to escalate around 1993, 1994. And so we experienced our probably our second resurgence in our long history, because of course the group was founded in 1936. So we had several goals in mind, because eventually we had to leave the planetarium at the Kalamazoo Public Museum because the place shut down, and it eventually reopened as the Kalamazoo Valley Museum, and we didn't really meet there very long. And so we eventually came here. Mike said, hey, we have this great presentation center, you guys can meet there from now on. And it was probably the best thing that ever happened to us. You might think, oh no, we can't meet at the planetarium anymore, where we've been for years, but it worked out the best. Because for the first time, we had to find quality guest speakers. We had to have people come to the Math and Science Center here to give monthly presentations at the meetings. And so we've had many great presentations. We've had, of course, many amateur astronomers in our own club and other clubs and from around the region. We've had professional astronomers from the surrounding colleges like WMU, Albion College, Central Michigan University, and beyond. And but I will say, out of all those speakers we've had over the past 20 years or so, I think Terrence Dickinson is my favorite, even though his presentation lasted 2 hours long. But it was a really, really good 2 hours. So then many members like Dave Moore and Dave Garden, they really wanted to get a observatory at the Nature Center. We had been meeting or holding observing sessions at the Nature Center for the past several years, and we didn't really have anything out there. And then finally, around 1998, we finally dedicated Owl Observatory. And then a few years later, we did a fundraising for the partial solar eclipse on Christmas Day to get a 12-inch LX200 inside the observatory. And so now we have the observatory out there. It could use another upgrading since it's been many years since we got the 12-inch, but that'll be a project for another day. And when I first joined, we had wanted to revamp the newsletter. First Pete Mumbauer did it, and then I took over for the next 6 years. I had a brief break, thanks to Mike Sinclair and Robert Wade, but I've been doing it ever since. And so the most recent issue, I think, was my 178th issue. And so then finally around 1996, when websites started becoming prevalent, we wanted to get a really good website. The very first website was done by a student right here at CAMSI. He uploaded it once, never updated it, and then I finally decided to figure out how to do web paging and put together the first website, and have been doing that ever since. And over the past 5 years, since I put the online membership form on the website, we've had a fairly significant boom in membership. So the website has really helped out. And one thing we really started to do over the past 20 years since I joined is we've done a lot of community outreach. We've been to Science Night at Vicksburg Middle School for the past 10 or 11 years. We've done stuff at many other schools like Kellogg Elementary, Plainwell Elementary. We've been to many other events, like this particular picture here was taken at the Pierce Cedar Creek Nature Center. And we've just done many other outreach opportunities. And of course we have some coming up, and I hope we can get some volunteers for those. And of course our key outreach event has been Astronomy Day since 2009. We've done Astronomy Days before that and received some honorary awards. But around 2009 is when Gene DeMont and I really started to increase the level of Astronomy Day, and we've had excellent guest speakers like Story Musgrave here. And out of all the Astronomy Days and all the pictures we've taken, this is still by far my favorite picture right there. So it doesn't get much better than that. Although the Spaceman in 2012 was also pretty good. And so you can find that picture online. And so when I first joined the board in 1996 as the editor/secretary, there were many long-term goals that I wanted to do. And some of those have kind of fallen by the wayside. Like we wanted to do a statewide star party, like a Michigan star party. But I don't know if I really wanted to do that. I mean, there now is the Great Lakes Stargaze up in north. But, this is Michigan. Holding star parties here would be very difficult because of the odd weather, and the Great Lakes Stargaze is in September, which is a very difficult time for many of us because we're back at work and stuff like that after like a summer break. And so the long-term goals that have survived that we still kind of strive for, and we do to a degree, are like the Schoolyard Stargazer program. This can be as simple as just, say, going to a school and setting up a telescope either during the day to look at the sun or at night to do some observing. But perhaps, we need to increase that in the future, do more, like give presentations and demonstrations. We can do a brief presentation about comets and then help kids make a comet. We can talk about the constellations and have the kids make a planisphere. We can talk about the sun and do solar observing. But other things we want to try to do to really increase it is one day purchase a inflatable planetarium and then just go around to all the area schools and set up a planetarium, and then we can do planetarium shows and teach kids stargazing and stuff like that, because none of the Kalamazoo public schools go to the local planetarium anymore. They can't afford it. So we can kind of fill that void that was taken up when the old planetarium shut down and reopened. And then we also wanted to get dark sky property. I mean, I've been doing this for a long time now, and every once in a while, like every couple of months, I'll receive an email from somebody that says, where do you go observing around here? Is there a place you can go to set up your telescope that's safe and where you're welcome at night? Because of course, many of the parks around here shut their gates at night because they don't want the more nefarious type of people in there at night doing whatever it is they do. So there definitely is a need for a piece of dark sky property in the area. And that's what we started to work on in the early 2000s when Jean DeMott here began her perpetual plant sale. And so up until the start of the project around 2008, 2009, she had raised enough money through plant sales alone to at least make a down payment on a piece of dark sky property. At the time, we were looking at some place up in Allegan where we were hoping maybe we had a bit of a buffer, but there's probably no true buffer anywhere around here from light encroachment, from light pollution. And so then around in October 29th in 2005, we held a little retreat called KAS at the Crossroads. And so many of these people are here tonight. Like there's Frank and Jack, and I don't believe Mark is here tonight. Rich is here. Andy is here, which is a rarity. We hardly ever see Andy here, so it's great to have Andy here tonight. Dave Wolf couldn't make it. He's singing at Miller Auditorium tonight. Robert Wade is still technically a member, but he lives in Connecticut now. But I don't care about him. It's his 20th job I missed, so that was nice. And there's Gene and Chris there. He had to move elsewhere for a job. And so we basically met and try to come up with long-term goals for the club. Everyone wrote things down of things they would like to see the club do in the future, and we wrote them on all these big white sheets. And so here's Robert Wade posing next to our list, and that we came up with. And can you see what he's pointing at? Because that was the one thing we thought we would never have a chance to do. So there's quite a few things on that list that we should definitely do. Some of which we've done, like minor stuff, like the storage facility. We have a storage facility now, which has freed much room in our houses. And there are many other things in there, but notice he's pointing at remote access equipment at a distance, because that is the one thing we just dreamed about, but never thought we would have a chance at. And so then that changed. It was at the January meeting in 2008, that's where Mike Sinclair here was talking about Simon Newcomb. And after the meeting was over, Mike Patton walked up to me after the meeting, right outside the area here, right by the greeting table, and he says, "Hey, I just purchased this piece of property at the Arizona Sky Village," which I knew all about. I had heard about it many times. And he says, I'm currently building a house. I'll be building my observatory very soon. The observatory is going to have room for 4 piers. And if you guys, if the KAS helps me with advice, and other help on the observatory and equipment he would like to purchase, he would give us a pier for free. And I was like, okay, that sounds pretty good to me. And it only took me like a nanosecond to think about it. But of course, the decision wasn't entirely up to me. It is called the Kalamazoo Astronomical Society, not the Richard Bell Astronomical Society. And plus, we basically had no money to start. We were starting from the absolute rock bottom. And then so about 2 years went by, because in 2008 we were busy planning for the International Year of Astronomy, and then in 2009 we were busy working on the International Year of Astronomy, because 2009 was the year we did that first big astronomy day with Phil Plate. I'd worked on a very long time for that because I wanted it to be like a big super event at Miller Auditorium. I was trying to get money to get Neil deGrasse Tyson here. I got very, very close, and then finally realized, the guy doesn't do weekends. He does not speak on weekends, and so that threw the whole thing out the window. And so months of work just got washed down the tubes because his agent was a complete idiot and had no idea of his needs. That should have been the first thing they told me is, he doesn't do weekends, by the way. Well, we'll just move on to somebody else then, instead of being wasted 4 months scrounging up money. So then at the holiday party in December of 2009, we took a vote. We had 3 options. Number one, keep pursuing the dark sky property, which is what we were working on at the time. 2, abandon the dark sky property project and then start pursuing the robotic telescope project. And 3 was just to forget both of them. And by far, most people voted to pursue the robotic telescope, which is why I'm up here talking to you today. And then a short time later, just 2 days later, the board had their monthly meeting, and we officially approved the formation of the committee. And I believe there are currently 8 people serving on the committee. Of course, there's me, Gene DeMont, Mike Cook, Don Stillwell, Daniel Flanagan, Bill Nigg. Who else am I forgetting?
Me.
Rich Mather, I didn't mention you already. Kevin Jung also serves on the committee, although he can never really attend meetings that much because he lives up in Grand Rapids. But he's provided some input here from time to time. So we've had many dedicated members serve on the committee and make valuable contributions. Oh, I should of course mention Joe Borello as well, which I will hear shortly. And then finally, when we had approved the project, we began to meet. We kind of came up with our plan, and our kind of first objective was to create a facility use agreement between the KAS and Mike Patton. You know, sure, Mike Patton had talked to me about the project, but you know, I could walk out the door here one day, get hit by a bus, and of course, all the agreements and deals that we made are out the door. So we had to have an agreement between the KAS itself and Mike Patton, and plus that proved valuable for grant keeping, because just recently I got an email from the Gilmore Foundation and they wanted a copy of it. So I went and sent them a copy. And so we signed the agreement at the November 5th meeting. And unfortunately, I couldn't be there that night because I was suffering from the norovirus. And the bulk of the credit, I mean, by far, most of the credit to the agreement goes to Joe Borello. I mean, frankly, I didn't want to do it. I just didn't really enjoy working on that sort of thing. And so I was really hoping somebody else would take it on. I mean, if nobody else stepped forward to work on the agreement and it was stuck with me, we might still be working on it, because I just really don't like doing stuff like that. So he did a really great job on it. Everyone provided input, but by far he wrote it and seeked out some lawyers to look it over for free, and it turned out to be a very good agreement. And then we finally began the fundraising in September of 2011. You might think that's quite the gap here, a gap there, nearly over 3 years. But we were in no hurry, of course, because around 2008, as you might recall, the economy was in the tank. I can even recall getting a email from the Gilmore Foundation saying, "Hey, our stock is really bad. Don't expect to get any grants, any major grants anytime soon." And I was like, "No problem. We're in no super hurry." But finally, things got better, and we decided to finally start pursuing the fundraising in September of 2011. And the initial results were really, really good. So I was very happy about that. A lot of people didn't just vote to support the project; they put their money forward. And then finally, just this year, in February, we wrote the grant to the Heart of Cook Foundation from the Cook Nuclear Plant. We should be getting a letter about that any time now. I was kind of hoping we might have something here tonight, but it might be another week or two before we get something. And then in early March, we sent out the grant to the Gilmore Foundation, and then another grant to the Monroe Brown Foundation. I'm fairly certain Gilmore will come through for us, because we've done a really good job on Astronomy Day, and they provided much of the funding for that. But some of the other ones I'm not so sure about. So I'm pretty sure we're going to have to write other grants, or at least redo our current grant and send it out to other foundations to try to get the rest of the money. And of course, I wrote like the first draft, and then I had Joe Borello make some changes, And then probably the most valuable contributions were from Molly Williams. So I'm sorry Molly couldn't be here tonight. Both her and Roger are at the symphony. And but she deserves a lot of credit for really helping shape the grant into place. And I should also thank the other members of the committee, especially Don and Rich, who apparently hate dashes and hyphens and stuff like that, and they don't like it. So now about the Arizona Sky Village. So the Arizona Sky Village is located in southeast Arizona, and it's located 1.75 miles northeast of the town of Portal, Arizona. And if you can't find it, hopefully the star guides your way. There's Portal, kind of lost in the mountains there a bit, and the little star is approximately where the Arizona Sky Village is. I'm sure it's somewhere in the area of that star, but that's a pretty rough approximation. And it's roughly 108 miles east-northeast of good old Tucson over there. So there's Tucson, and so it's a pretty fair distance away. And so the Arizona Sky Village was founded by Jack Newton and Gene Turner in 2003. And so here's Jack Newton with his wife Alice. Alice Newton gave the raciest talk at the 2005 Winter Star Party. I really wish I could have got a recording of that because we were kind of blown away by that. That was something else. And so I can't really describe the details of that. So it was pretty good. And Jack Newton, as many of you may know, is a very accomplished astrophotographer. And so many of his images have been in like Meade images because Meade provides much of his equipment, some of which he may or may not have to actually pay for, which is a very nice thing to have happen. And so you've probably no doubt seen his images from various places. And Jack is from Canada, and he and Alice have a bread and breakfast in British Columbia. And so here's their bread and breakfast there. This is an actual photo. This is a composite. You can kind of tell the tree line looks a little funny there, but it gives you a sense of what they expect the dark skies to look at. I did not make the composite. This has been lifted off the internet. So Jack and Gene began looking for a piece of dark sky property, and there's Gene Turner. He is a developer from Florida. And apparently he knew Jack Newton because Jack Newton was at the Chiefland Astronomy Village in Florida. And basically Gene said to Jack, you're in the wrong place. I have a much better location in mind. And so they started scouting out spots and found that piece of property in southeast Arizona. And so it's composed of 450 acres in the foothills of the Chiricahua Mountains at the mouth of Cave Creek Canyon, which I'm guessing this is Cave Creek Canyon right there. Is that right, Mike? Okay, so there you go. And so they kind of parceled out 85 lots total back in around 2002, 2003 or so, and they sold out fairly quickly. What year did you buy yours, Mike?
5 years ago.
About 5 years ago? Okay, so they didn't sell out really, really fast.
No, I was at a secondary sale. A guy backed out and I was able to get in.
I see, okay. And so there are 85 lots. I believe there are currently about, a dozen houses that are currently built. So there'll be many more houses added to the area. And there are also 11 timeshare haciendas. What's the status of those? Are those all taken up too?
There's 2 available at this time.
Well, there you go. So there's 2 available. So somebody write a check. And so the Arizona Sky Village has fairly strict lighting ordinances. No outdoor bright lights. When it does get dark, you have to at least shut your windows or turn your internal house lights off, or at least probably shield them in some way. So they have very strict lighting, and so it is a community specifically dedicated for amateur astronomers, but birders, archaeologists will also enjoy being in the region. And so there are actually 2 other developments nearby that Gene Turner started, after the Arizona Sky Village was all bought out. One of those is just across the border in New Mexico called Rancho Hidalgo, but it's not quite the same as Arizona Sky Village. It's not a community for amateur astronomers. It's more of a place for individuals and colleges and universities and others to set up observatories. Here's a remotely controlled observatory here, and also both Astronomy Magazine and Celestron have small roll-off roof observatories on the premises. I'm guessing the Celestron Observatory has meat telescopes inside of it. And also nearby in New Mexico is Granite Gap. And I got to go there when Gene and I paid Mike Patton a visit in 2010, but there really wasn't hardly anything there at the time. I did see one of these small cabins, as they call them. They're about 400 square feet, I believe, and you can get a timeshare on these for about $14,500, and you get to use it 6 months out of the year. But if that's a little pricey for you, they do have something much more affordable. I mean, even I could probably spring for it. Is for a 99-year lease. They let you purchase lease a third of an acre to at least set up an observatory. So if you want your own kind of small observatory out west, you can get it for about what's the price on that? $2,500. So that's not too bad. And so let me give you a little tour of the town of Portal. It has a population of about 100. So there are only 100 residents in Portal. And just FYI, it is a unincorporated town, but it does have a zip code, as you can see. So there's the post office. And right nearby is the Portal store. We never actually got the chance to go in there. They still have a phone booth, too. So it's like traveling back in time. And that's it. That's Portal, Arizona. As I recall, there are some private houses right in town, right? There are some houses right nearby in town.
There's a library actually right next to the post office. We can get any book in the world within 2 days.
I missed the library?
You missed the library.
How did I miss that?
Does that have a sign on it?
I'm missing 1/3 of the whole town.
Richard, you blinked.
Yep. And so let's take a quick tour of Arizona Sky Village. When you first drive in, you'll go by this twin-domed observatory, which they affectionately call Dolly Parton. So I'll let you absorb that. I have no idea what's inside there, so don't ask. Mike, do you have any idea what telescopes they have in there?
There's two very large refractors, and they're run remotely out of California.
Okay. By club or private individual?
You guys.
Two guys? Yeah. And here's another nice observatory. I forgot who you said owns this one. I know I mentioned it in the email, but I forgot already. Do you remember either?
He's a neurosurgeon in Philadelphia.
Okay.
Roy Furman.
Roy Furman? Yeah, that's right. And Fred Espinac has a similar looking observatory to this, but I believe it's 2 levels. And the dome is a little wider. I didn't get any good pictures of that one. But of course, the most famous residents, aside from Fred Espinac, because he's very well known for eclipses, is Jack and Alice Newton, affectionately called the Stargazers. And so they're probably only there during the winter months when their observatory and bread and breakfast in British Columbia is probably under like 8 feet of snow or something like that. So that's a pretty good place to go. But they do not offer their home and observatory as a bed and breakfast here. But Jack Newton does offer like courses here and how to take pictures and stuff like that. So there's the home of Jack and Alice Newton at Arizona Sky Village. And the largest home right now is owned right next door to Mike Patton. So these are his closest neighbors, I believe. And this is the home of Rick Benno. And his observatory seen there above center is called Conferring with the Sky. And we had the opportunity to meet Rick Benno in 2010, and we even spent a night observing through his 16-inch in that observatory right there. So we had a nice night checking that out. If you recall this old article from Astronomy Magazine back in February of 2008, he used to have the 16-inch in his main observatory, but he has since upgraded. He now has a 24-inch plane wave, which you can go to the website and purchase for yourself for $50,000. That's just for the telescope. So we hope to have something not quite that big, but pretty comparable, right nearby. So he had to put out a fork mount because of the way his pier was built for the LX 200. So you can see it's a bit off center. So a fork mount had to be used instead of a German equatorial mount. But even the newer Paramount would not have supported this thing. You would have had to use a much larger equatorial mount. So a fork mount was probably the best thing to use anyway. And he also has a very nice Epsilon 180 ED astrograph, a very wide field Newtonian. And this is also serial number 1. So this is the first of its kind made, and he has it. And so he was kind of their test subject as well. And there's the home of Mike Patton. And according to Mike, right, this is the back of the house, right?
I guess.
But it's this one that faces the road, right?
That faces the
so
mountain.
to me it's to me it's the front of the house, but according to him this is the back of the house. We had a debate about that when I was out there. And so here's the front of the house, which faces away from the road. And here it is. Here will be our home away from home for our robotic telescope. And we did have a observatory naming contest, but apparently the winner was nobody. And Mike decided to call it the, let me take a shot at this, the PECE Observatory. PECE?
It's Apache.
Yeah, it's Apache for Nighthawk.
Oh, perfect.
We'll have to have a whole training course on how to pronounce the name. And so if you've ever looked at the Robotic Telescope website, you've no doubt seen this picture before. It's been on the website for quite some time now. And here it is from a different angle. So the roof rolls off toward the north, right?
West.
The west, okay. And then he has the computer room here. And there's our empty hole. So we're hoping to fill this empty spot in the observatory in maybe the next year or so. You know, we're hopefully getting very close to actually start to put stuff in there. Just looks very lonely in that corner. We need to put something there. And so they're the two together in their natural setting. What's that white stuff up there? I don't know.
Don't even say it.
Okay, so the Arizona Sky Village near Portal, Arizona is 4,600 feet above sea level. So that'll ensure relatively low humidity, much lower than we get here. So here you can see Portal again. It always gets lost in the mountains there, even the topographical view of the mountains. And so again, it's about 4,600 feet. And the average high temperature during the summer is about 90 degrees, and the average high in the winter is about 58 degrees. And but as you can see from the chart here, the median temperature throughout the year is in the like mid 60s or so. And it is, of course, in the Arizona desert. And so the total annual precipitation average is only about 17.4 inches. And most undoubtedly, most of that is during the monsoon season from June to August. But, of course, during the winter, they can receive snow. But according to like Rick Benno, Mike Patton, if it snows one day, it's usually gone by noon the following day. So hopefully snow won't be a major issue out there when we're trying to use the telescope. So this probably the night before probably wasn't one of the good nights for observing. But the area, at least according to the article in Astronomy, I kind of find it a little hard to believe, boasts 350 clear nights a year. And through my research last year for the talk on the summer Milky Way, I kind of calculated an average of 70 clear nights a year for us. And I'm sure roughly half of those are during like a full moon too, like a bright gibbous moon or something like that. So what I should mention here that pretty much, or really I think all the astrophotos, except for a couple, were taken from Arizona Sky Village. This particular one here is from Fred Espenak that I sort of liberated from his website. And right nearby the Arizona Sky Village is the Coronado National Forest. And that's a really fun place to check out. Again, if you're into birding, and because you'll see all kinds of rare birds in the area. And it's also very large, 1.78 million acres. And again, it's a really neat place to check out. So here are just a handful of photos that I took when I was there in 2010. I don't believe Jean got to enjoy the tour as much because she was suffering from altitude sickness and left a nice little trail all over the Coronado Forest for us. So in case we got lost, we were able to follow the trail on the way out. This is the view on the way in, so we're not even at the National Forest yet. And so we see some of the nice scenery. I'm just going to kind of slowly go through the images here. I don't have a whole lot to discuss here, but if anyone knows about the geology of the area, feel free to share a few tidbits here.
I should mention that the Cave Creek Canyon area is the home of Geronimo and Cochise in their final years. So a lot of archaeologists are out there finding pottery shards and arrow points, etc.
Oh, good. There's the Bat Cave there. This is a panorama I stitched together. Turned out pretty well. And there's Mr. Wonderful himself at the corner. All right, so of course the major advantage of the Coronado National Forest is it's of course very large, and national forest land cannot be developed, and so the bulk of the national forest is over here, and some of it does spill into New Mexico as well. So this will act as a huge buffer from light encroachment for the foreseeable future. Arizona Sky Village should not suffer from serious light pollution anytime soon. So it'll stay dark for a very long time. And so here's a light pollution map created in 2006. And this is what the clear sky chart uses to rate sites using the Bortle scale. And so this is both from the 2006 survey website and the clear sky chart. So the absolute darkest skies on Earth, like the middle of like Africa or the outback of Australia or the middle of the Pacific Ocean, are on a Bortle scale of 1. There's absolutely no light, artificial light for likely thousands of miles, and so this is as dark as it can get on the planet Earth. And so Arizona Sky Village, seen right here, of course, is a Bortle scale of 2. It kind of borders between these two colors here because each scale has several subcolors. Many of them do anyway, and so you can see we'll enjoy dark skies here for a very long time. Of course, there's nearby Tucson, but again, recall that's 180 miles away, about 2.5-hour drive. It's probably like a good 5.5, 6 hours, or maybe a little less, to get to Phoenix, which is horrifically bad for light pollution. And that goes for El Paso as well. And then we drove through El Paso after a Texas Star Party, and that's just a really sick town for urban sprawl. But we're provided a major buffer by the Coronado National Forest. And here's an all-sky view of the Arizona Sky Village that Terrence showed during his talk back in 2011. And so this shows the winter sky. And so this is the winter Milky Way here. You can just make out Orion, Taurus, the Pleiades, Canis Major. There's Cassiopeia up there, and of course you can see some bits of light pollution on the horizon. One of those is from the nearby town of Lordsburg, which you could not see on the map. I didn't label that because it would kind of cover up other features. But that's off to the northeast, because I did sort of turn this image so north is roughly at the top. In fact, this is the North Star right there, and off to kind of the southwest there is Sierra Vista, kind of a series of 3 towns nearby, and that's the bright one. I'm not really sure. I could never positively identify this little dome here. Because there are no real towns labeled nearby, but perhaps it's some truck stop or some road stop or something like that. And you might wonder, what's this? This looks like some major light glow here, but there's nothing you can do about that. This is the zodiacal light caused by dust in the planet of the solar system. And it's caused by asteroids and comets. As they shed their dust through space, it gets reflected. The sunlight reflects it and creates this zodiacal light. And so, seeing this is a sign of a good sky. And really, even from the darkest sites, it can be so bright it's actually really annoying. But you just can't do anything about it. And you can also see the Gengenschein at the Arizona Sky Village. It's not shown here, but that's German for counterglow, and it's basically the same thing, dust, but in the opposite direction, the exact opposite direction of the sun. But I don't have an image of it here. It's just a funky glow high in the sky. So the telescope has many advantages, some of which we've already touched upon. Of course, the advantage is you can, if you have the opportunity, you can set up the facility at the darkest skies you can find. And so that's what Jack Newton and Gene Turner have done, because the Arizona Sky Village is at one of the absolute darkest regions in the U.S. There are regions just as dark, in Michigan. Mostly in the upper peninsula, but of course in Michigan you still have bad weather, and so you can also set up your facility at a region with better weather, 350 clear nights a year, and superior sky conditions. At their higher elevation, it's always going to be drier here, and the sky is always going to be much more transparent. So their best night will always outdo our best night. And we've had some pretty good nights here, but nothing compared to what you can get out there. And of course, you can try to set up in a location at a lower latitude, and you can begin to observe objects you just simply can't see from Michigan. And these 2 images here are the only images I show that are not from Arizona Sky Village. This is Omega Centauri, which looks smaller here, but this is a wide field image. Omega Centauri is a very large globular cluster, a massive collection of hundreds of thousands of stars. Omega Centauri likely numbers upwards of 10 million, and it dwarfs M13, the best globular cluster north of the celestial equator, the one we always show people during the summer. So I've got to observe Omega Centauri both from West Texas during the Texas Star Party, and also from the Winter Star Party down the Florida Keys, and it is an absolute treat. It is gigantic and just a thrill to observe. Another personal favorite that we can't observe here, it technically does get above the horizon, but we're talking like a degree at most, is Centaurus A, a large elliptical galaxy that apparently gobbled up a dwarf spiral galaxy. And so you can see that from Arizona Sky Village. And so we'll be able to check out stuff like that through the telescope. Of course, there are some disadvantages. Can you guess the first one? They're really expensive. It's really all a matter of how much you want to put into it. I mean, you could use stuff from Orion or Meade or Celestron and make a pretty good go at it. But my sort of philosophy is a premium site deserves premium equipment. Plus, if something's that far away, you're going to want it to be reliable and last for a very long time. But our project, the general total is around $100,000, but the actual total is, the amount I requested in the grants, the total I mentioned in the grants is around $115,000, for equipment and for future expenses, and some of us are going to have to travel out there to install this thing, and so on. And of course, it's going to be pricey to maintain. We're guessing we're going to have to pay around $1,000 a year for insurance alone. But we're hoping to cover that cost mainly through additional member fees. Because if anyone thinks they're just going to join the KAS for $20 and use a $100,000 telescope, that's not going to happen. Even a club like the Grand Rapids Club, which has Bean Observatory, they charge an additional $25 on top of their membership fee, which is higher than ours, just to use their observatory, which nobody hardly ever does, because it's Michigan, you have to drive there in the cold, but this you'll hopefully be able to use from your basement or your computer room. And so we'll also try to rent the facility as well to private amateurs outside the region and maybe colleges and universities. And if something does go wrong, we might have to travel 1,800 miles to fix it. But of course, the major advantage we have is the Arizona Sky Village is filled with fairly hardcore amateur astronomers like Rick Benno has already promised to help us out from time to time, but we're hoping we won't have to bother him maybe more than a few times a year. And I've done some research. I've contacted other area astrophotographers, like Rob Gendler. He's that physician who lives in Connecticut, but used to use a remote facility in New Mexico, and he even used one in Australia. And he said problems came up maybe a few times a year and stuff like that. So we can expect problems to come up a few times a year. But again, we're trying to get the best equipment we can afford, or at least that we can raise money for. And so the KAS robotic telescope will have the following uses. The main use we really want to do is a new type of observing session. Because we hold sessions here at the Nature Center between April and October, and roughly half those are clouded out. On the clouded out nights here during the public sessions, we just can't use the robotic telescope, because you got to remember it's going to take an extra 2 hours or so for it to get dark there, because they're 2 hours west of us in the standard time zones. But during our off season for outdoor observing, we're hoping to hold indoor observing sessions with the robotic telescope between November and March at places like the Nature Center. Likely we'll do some here at the Math and Science Center. We'll do some at Western, maybe some at the museum, and we'll try to move it around, because the advantage is we can do these anywhere. They have high-speed access. And so we're hoping to show wide field constellation images with a wide field camera, and maybe closer up stuff with the big telescope. And along the way, we can pass along some of the information about what we're looking at. But there's this one thing I want to reproduce, and Mike will remember this because I think Mike is the only one that is still around that was there that night. But several years ago, back in 1995, 1996 or so, we were out at Astropad, which was Dave Moore's observatory. He's since moved out of the area. And Pete Mumbauer, again, Mike and myself. And Pete was field testing a Celestron CCD camera. And he had hooked it up to Dave Moore's telescope. And he took an image of M16, with the famous pillars seen in the Hubble Space Telescope image. And we just freaked out when that image came on the screen, of practically a live view of the pillars right on the screen. And so I want to do that over and over again with the robotic telescope. I mean, yes, we could just, if the telescope breaks down, we could just pull images off the web and say, this is right from the telescope right now. But it's trust me, it's better when it's a near live image pulled down from the telescope just moments ago. So I'm really looking forward to doing that. And of course, the second primary use will be research by KAS members and students, like from right here at the Math and Science Center, at Western and Albion College, and anywhere in the South Michigan region, because we're hoping to let students use the facility in the area for free. For absolutely no charge, because CAMC doesn't have any access to something like this. Neither does Western students or Albion students, and so they'll have access to a premium telescope at a premium location, and so they can do work like spectroscopy, because we're hoping to get a spectrograph, as I'll show you briefly, and also like photometry with the CCD camera. And pictured here is a young astronomer named Piper Reed. And there was a recent article about her in the February issue of Sky and Telescope. And here's the picture I scanned out of the issue. And so she did spectroscopic work on close eclipsing binaries. She calculated their speed, the revolve around each other, and their mass, which is very important to determine the light of stars. She even took the spectra of Jupiter and Saturn, figured out their rotational speed, and she's just won gobs of awards for her science fair projects. And so we're hoping to help area students cash in lots of awards with our facility, because they will be able to use it again for absolutely free. And also, members and students can conduct searches for stuff like, of course, comets. They can maybe discover a comet or two. It'll be hard to compete with the big automated professional observatories, but amateurs still turn up comets from time to time. They can track down asteroids. It's actually a lot easier than you think it is. Even today, with all the automated surveys, amateurs can still discover asteroids. Maybe some student will discover the one that's going to kill us all one day. So you never know. That'd be good to know at least. Perhaps if we had the facility a few months ago, it could have been one of our members or perhaps a CAMSI student that discovered the recent supernova in M82. But we didn't have a telescope, so nobody could do it. And people could even do searches or again additional research on extrasolar planets that transit their parent star. So the sky's the limit. They could do variable star work and just all kinds of stuff. And of course, what many of us want to use it for as well is to take sweet pictures. Of course, the main thing we'll try to do, because many people might be a little intimidated to use such an advanced facility, because there might be a bit of a learning curve to figure everything out. Of course, we'll have training sessions, but we're just hoping to have imaging workshops too, where many of us just schedule some club event. We get together, we collect images for a night, and then we all share the images. and perhaps we can try to do our own processing, or we can do processing workshops as well. So this will help bring us all together, because one of the goals I strive for to this day is to help keep the society in Kalamazoo Astronomical Society. Sometimes it's hard to get people involved, and I'm hoping this will help bring us together even more. And of course, you can use it on your own. You can be in your computer room or whatever, and we're hoping that that you can just connect to the computer out at the observatory in Arizona, and use the facility for your own private use. And what I'm hoping to do is many of us can pool our telescope time, and we can just do, somebody can take the telescope on Tuesday, someone can take the telescope on Wednesday or something like that, and we can just do long duration images of the same object, and get one of these long exposure images. Like this image here, the Whirlpool Galaxy, is likely 20 plus hours total, so that's difficult to do in one night, so you need multiple nights to do it. And my ultimate goal for our images is, of course, we can put them on the website where people can go ooh and ah. Maybe we could even sell prints. People want to buy a print of one of our good images. We can make calendars. But one of my major goals is to create an astrophotography exhibit. This is something that the Art Institute here in town wanted to do with us years ago, but we just weren't quite ready for it. We could probably pull something together today, but let's do it with the high quality images from the robotic telescope. So we can have a display at the Art Institute. We can even do something at the museum, maybe during Art Hop or something like that. We can go down to the Krasel Art Institute in St. Joseph. And all around the area, we can share our images, do outreach and education, and just inspire people to check out the night sky. So let's check out the equipment real fast. So of course, our main telescope, if all the funding comes through, and it still may not, but we're going to exhaust every avenue we can, is a plane wave CDK-20 telescope. And this was made by, of course, Planewave in California, which is owned by two former Celestron employees. And so they wanted to start making higher grade equipment with their new type of corrected dull Kirkham telescope. A dull Kirkham has a ellipsoidal primary mirror and a spherical secondary mirror. But what makes it corrected is the lens group, which helps correct for coma, where stars look like little comets on the edge of the field of view, stigmatism, and helps give it a flat field across a 52 millimeter plane, which is necessary for the wide field CCD cameras that they have today, and of course what we want to get for the telescope. Whoops. And so here are the optical specifications. It's, of course, 20 inches in aperture. Far bigger than the telescope in Al Observatory. The focal length isn't too longer than the 12-inch, at about 3,454 millimeters. So that gives a focal ratio of f6.8. And the telescope weighs 140 pounds. If they didn't come out with the new Paramount, the new mount, we would not be able to get this telescope. But again, my goal is to have premium equipment for a premium site, and I want to get equipment that none of us could ever have a chance of owning on our own, unless one of us wins the lottery, and of course, hopefully the KAS will cash in too, right? And so you can see the telescope is a carbon fiber construction because aluminum tubes during the night can contract as it cools off. But carbon fiber does not change size with small fluctuations in temperature. So we won't have to bother adjusting the focus throughout the night. And of course, there's the current price tag of the telescope. But I should mention that OPT, Oceanside Photo and Telescope, they are giving us nice little discounts on all the equipment that we're going to purchase. But if we don't get all the funding that we want, we do have some backup plans, and they're both from Planewave. We can try to get the 17-inch, which is $22,000, or we can try to get the 14-inch, which is about $15,000. This one is so new I don't believe they've ever even produced any yet, but they should be out soon. And the $15,000 is the introductory price, but I think that price should be good all year. So, so if we, take the whole year to find other funding for the 20-inch, we can probably still get the 14-inch if we can't get the 17-inch. So we definitely have some backup plans as well. Of course, the 20-inch and even the 14-inch and 17-inch are fairly long in focal length, and they will be excellent for for close-up images of galaxies and planetary nebulae and globular clusters. But of course, we might want to do some wider field imaging as well, and so we can get one of the premium wide field refractors in use today from Takahashi. And so this telescope is called the New Q, and it's a modified 4-element double ED Petzl design. I won't bother going into the specifics about that, but the 4 different types of glass helps again eliminate the astigmatism, coma, secondary spectrum, chromatic aberration where you see like purple around your bright stars and stuff. Gets rid of spherical aberration and film curvature. They do offer a focal reducer, but it didn't work with the cameras that we wanted because there's just not enough room for focus. And so here are the optical specifications. Again, it's 106 millimeters in aperture, has a 106 millimeter lens, which is just over 4 inches. And you can see the focal length isn't nearly as long as the other telescopes, and it's only an f5, so it gives a nice wide field. And I'll show you some examples of what these telescopes can do. It only weighs 15 pounds and has a really heavy-duty 4-inch focuser. Dave Garden has one too, and he loves it. Okay, so here's our workhorse mount. This is what's in the box, right there. So one of these beautiful Paramount ME2 mounts is right there, and I'm anxious to check it out. I have not looked at it yet. And this is the current price of the mount, but we purchased ours just before the price went up because the old price, the introductory price, was $13,500, and we even got a bit of a discount from that. So this is the most expensive purchase so far the KAS has ever made. So that's why this is an important night here. So the mount has a 240-pound instrument capacity, which is much better than the old Paramount, which holds about 150 pounds. And it can hold a total of 480 pounds, because if you have 240 pounds of equipment on this side, you got to have 240 pounds of counterweights on the other side. And the mount itself weighs 84 pounds, although in the box, that box weighs 110 pounds. And this mount has belt-driven gears, because most German mounts, just use the regular type of gears, and they can have a little bit of backlash. As you move the telescope to the east, the gears spin one way, and then as you want to spin to the west, they kind of have to move a bit, and then it moves, and so that can screw up your alignment, and it makes it difficult to point at stuff. But the Paramount has virtually zero backlash because of that belt drive. And it has a maximum 7 arcsecond peak-to-peak periodic error before periodic error correction. And when you do the periodic error, it can track objects at long focal lengths unguided for about 5 minutes. I found 5-minute images of galaxies and stuff online that did no guiding, and the stars will absolute pinpoints. And so that's very impressive engineering there. And it has 30 arcsecond or better all-sky pointing with a little program it comes with called Key Point. So of course you don't want to hassle with trying to from 1,800 miles away, so you want a mount that can do it reliably for you. And one very impressive thing, if you ever used a German mount, is it can track or slew up to 3 hours past a meridian, because here you can see the telescope is nearly horizontal here, and if this were my mount, when it got to this point, where it's like the counterweight starts to get higher than your equipment, you have to flip it over and then realign your image. And so this mount doesn't have to do that. So that'll save us a lot of effort, especially again from 1,800 miles away. and it includes programs like Sky and T-Point again. And so here's the CCD camera we want to get, but multiply this by 2 because we need one for the 20-inch and we need one for the refractor, because we don't want to call somebody at 3 a.m. and say, okay, I'm done with the refractor now, or could you please move the camera from the refractor to the big scope? So, so we don't want to bother anybody with that out there. So we need to get 2 cameras. If we get 2 telescopes, but that depends on how much funding we get. And so this camera uses the now TrueSense, the new name for the company known as Kodak, because they're pretty much gone now. And so it uses the Kodak KFA 16803 image sensor. That's where they get the name of the camera. And so it's bigger than old 35 millimeter film. So again, it's basically a large format CCD camera. And I can just let you go through the information there. But the important thing for CCD cameras is the smaller the pixel size, the better. And so this is about as good as it gets.
Why monochrome, Richard, instead of...
Because it's higher resolution. Monochrome is much higher resolution than a color camera. And it's also better for research as well. And so, it doesn't suffer from noise as severely as a regular digital SLR camera, because it is cooled. It has a heat sink in it that keeps the chip very cold, colder than the air, to reduce noise. And of course, it has USB 2 interface. So quick download times. Only weighs 5 pounds. And we'll be getting the 7 filter wheel. They do have a version with 5 filters, which means you can use the guiding in the camera. But we want a variety of filters, and we can't ask anyone to change them out. So we need the one with 7 filters, which means we need a separate remote guider. But I don't show that on here. I don't show you every little piece of equipment we plan on getting. And we want to use the Astrodon filters on the camera. Now I'll just kind of go through these real fast. Here are the basic ones. You always start, most of your images will be with a luminance filter, which is just a clear filter. And do a very long luminance filter of the image. And then you'll create the color with the red, green, and blue filters. And again, you want to get a monochrome camera because they are higher resolution than a straight color camera. And we'll also try to get narrowband filters so we can observe image objects at specific wavelengths. And the narrower the slits, the sharper the image. And so 3 nanometers is as tight as you can go with the narrowband filters. And so we want to get the following filters. Hydrogen alpha, that's mostly what those bright pink emission nebulae, like the Orion Nebula, give off. They mostly emit all their light in hydrogen alpha. And objects like planetary nebulae can give off O3, so we'll get an O3 filter, and also a silicon filter. And one of the advantages of narrowband filters is they can be used during a full moon. So we can image right during a full moon because these wavelengths are not really bothered by moonlight. So we don't have to wait for dark skies even to use the robotic telescope. And the pack of 4 is this price, but these narrow filters, these narrowband filters, are very pricey. And so this is the cost of each of these. Well, these 4 together are this price. So they are very expensive. But remember, premium site, premium equipment. So here's the good part. Some of the images you can take with this thing. This is NGC 6946, called the Fireworks Galaxy. And this was taken with the 20-inch plane wave, but an older style, an older 11 megapixel S-Big camera. And it used the older Paramount, and then again the luminance, hydrogen alpha, and the red, green, blue filters for a 15-hour total exposure. So that's why I'm hoping several of us will team up and take images like this, because It is sweet. And here's a close-up of the Rosette Nebula with the narrowband filters. So again, this was taken with hydrogen alpha, O3, and silicon. And again, it just gives stunning images. And so you could do something like this during a full moon. And that's 32 and a half hours long.
Richard, you and I are doing this. You and I are doing this.
Okay. All right, now how about the Takahashi? Because again, it gives much wider fields of view. And this was taken with the exact scope and camera we want to get. This is as close as I could get. They didn't use a Paramount though, so, but this is pretty close. So here's the Andromeda Galaxy, and this is the full field of the chip used on that telescope. So the Andromeda Galaxy is like 4 degrees across at its brightest. So that's 21 and a half hours of the Andromeda Galaxy with our, hopefully, future
Would this be an
equipment.
example of course we may be able to see it in color and so forth, but would this be an example of what we could see real time?
Right. And when we do the remote observing session, all our images will be in black and white anyway,
Right.
because color takes too long. Okay, and also I have to show the Orion Nebula too with the Takahashi. That's only 4 hours, so that's a single night of imaging with the telescope.
And Richard, does that mean 1 hour each color and the
Yeah, I
clear?
assume so. Yeah, probably mostly for the luminance, and then separate, smaller, shorter exposures for the red, green, and blue. But they didn't have the exact imaging data on this image.
So that's the total time.
Mm-hmm. Yeah, that's the total time, not for each filter. Okay, so real quick again, here are some other pieces of equipment we want to get, at least the major stuff. Again, one of the primary uses of the facility will be for research from either colleges and students and stuff. So if we're really serious about doing research, we have got to get a spectrograph, because that's where most research is done today. The only thing I'm not sure about is if this specific spectroscope can be used remotely, because again, they can't go out there to use it. They could, I guess. But primarily, they'll probably use it from the area. So I need to do some more research on this, because it does look like you have to make some finger adjustments on the wavelength instead of that. But we'll have to check into that. And so this is made by Sheliak, which I believe is a company in Germany. It's hard to read their website because the English translation is not very good in this part. So it's kind of hard to read at times. And then we can't be out there to change the camera, to turn it to different angles, and so we'll have a image rotating focuser. It acts as a focuser too, and it's pretty heavy duty. And of course, we can't walk outside and check the skies. Of course, we could, but here it'll probably be cloudy, and out there it'll be clear. So we're going to hopefully get a all-sky camera that gives views like this. So, of course, we can check to see what the skies look like, see if it's cloudy, or it's clear, or if there are drifting clouds. And of course, we'll have, Mike has other weather equipment in the observatory to tell us wind speeds and temperatures and stuff like that. Although, like Fred Espinac has all that information on his website for free, so we can use Fred's website. And since Jean has raised quite a bit of money with her perpetual plant sale, she has said we need to get this. Of course, she didn't mention the specific equipment, but she wants to do wide field images of the constellations during the remote observing sessions, because we hope to take wide field images of the constellations, closer up than the all-sky camera, and then, show people the constellations from out west. We can kind of say, here's Orion. Now we're going to check out Orion close up through either the Takahashi or the 20-inch plane wave. So this is something we also hope to get. And in this case, we will just get a color camera, because we're not worried about doing really good imaging. But we can do wide field surveys too. We can do stuff like Axel Mellinger and do wide field mosaics of the Milky Way with a camera like this. Okay, so that's pretty much it. As usual, it went longer than I expected, so I'm sorry about that.
No.
Are there any more questions about the robotic telescope, any of the equipment, the location, fundraising, anything? Nobody? I will be available for questions during the break. And by the way, I'm glad our robotic telescope will not look like that, because as soon as we turn it on, you know what it's going to say. Kill all humans. And so, before we move on to the unboxing ceremony, I just want to take the time to thank all these people and some of these organizations for providing funding for the telescope. This was the accurate list until apparently Jim Kurtz brought a check in from Tim Kurtz. So we can add Tim Kurtz to this list as well. Many of these people are also multiple donors. And again, it was my long-term goal, or at least my hope, to say on the grants that every member gave funding. But of course, I couldn't quite do that, but it's still not too late. So if you have not provided funding for the robotic telescope, your donation is still more than welcome. $5, $10, $100, $500. We've of course gotten larger donations. And so, whatever you think you can give, please give to the robotic telescope. The grants are out there waiting, but it's not too late. Your funding is still needed for this project, the biggest in our 78-year history. So thanks for listening. Okay, you guys ready to check this thing out?
Yes, look in that box.
All right, so we need some committee members to help. Like, Don, do you want to give me some help? And
Housewives?
I brought oh, that's the wrong button, isn't it?
Yeah, wrong button. Second one right there.
That one right there?
Second one.
That's the third one.
No, second one.
This one.
Right there, press
Right
it.
below the red line.
Yeah, press it. Press it. Good.
So, where are we going?
There it is.
I brought a special tool to get this thing out of the box.
So I'm ready to go.
All right. If anybody else that's on the committee wants to help, you're more than welcome.
Yeah, let's go ahead and get it on. Drop it on. And the first one you give me.
Oh, my spleen! I love doing that.
Don't need that anyway, please. And the first one gets to give it a kiss.
Don't kill yourself, Don. That's 80 pounds right there. So. All right, are you ready? All right, I'm gonna break the seal.
Don't cross the streams. Don't cross the streams. Yeah.
I'm glad I'm not a surgeon.
Prepared.
I think I just killed the patient. I gotta read the directions first.
Oh, that would be good.
$4,000 in packing here alone.
Wow.
I hope it's right side up.
Wait. This isn't like the Ark of the Covenant, isn't it?
All right, wow.
Holy crap.
Okay, let's
Just lift
come
it up
on.
there.
Rather than lifting it up,
What?
everybody want to come out.
Lift it up.
No, let's get it on the table.
Oh, you do?
Yes.
All right. God. I'm giving you the heavy end, man. Wait a minute.
Oh, hold on. That thing is
Yeah.
cold.
That's very
Let's
cool.
flip it over and get close.
Yeah, all right.
Get that out of the way.
Don't worry, baby, you'll never be this cold. Although it's pretty cold out there.
Lift with the knees.
We got cleaners here.
Awful. You got it.
See if we can get it out of the bag.
Nope, okay.
Man, I didn't get it all the way.
Wait a minute.
I'll lean it back the other way. I gotta say, this is mostly, the cost of this thing is mostly from what Gene has raised. So it's okay if I hug it, you guys mind? Turn the other way and just don't look. It's fine.
Give it a hug.
All right, so come on up, check it out, and then we'll have a special Paramount unboxing cake.
And what's in the Paramount right now?
This counterweight, we can go ahead and open that one too, but it's mostly counterweights and stuff.